Hello, my dear students. Welcome back on the lecture on details of GPRS. In this lecture 6, we are dealing with the GPRS network protocol. The abbreviations that are used in the diagram of the network protocol or in the details of the network protocol are SNDCP for subnetwork dependent convergence protocol, LLC logical link control, RLC radio link control, MAC medium access control, PLL physical link layer, RFL radio frequency layer, BSS-GP, BSS-GPRS protocol, GTTP is a GPRS tunneling protocol, TCP is transmission control protocol, and IP is the internet protocol. This is the diagram of the GPRS network protocol. This is how the GPRS networking protocol is divided into MS, BSS, SGSN and GGSN, and how the data is interchanging between these. You can see there are network layer, data link layer and physical layer. Physical layer has two parts, PLL and RFL. Data link layer has three parts, LLC, RLC and MAC. And network layer has three parts, application, network layer IP and SNDCP. So we go to the details of it, how this works. Transmission protocols in the interface that you can see in the diagram below here. The interface, what are the transmission control protocols in the interface that you can see in the diagram below. A physical layer. Number one is the physical layer. The physical layer can be divided into radio frequency RF layer and the physical link layer. You can see here back in the diagram. The is dealing with the RFL and the PLL. We can see through the abbreviations that PLL is a physical link layer and RFL is a radio frequency layer. So we go here. What is physical layer? It is divided into radio frequency RF layer and the physical link layer. The radio frequency or RF is the normal GSM physical radio layer. It performs the modulation of physical waveform based on sequence of bits received from the PLL. RF layer specifies the carrier frequency characteristics and GSM radio channel structures, the radio modulation scheme used for data, the radio transmitter and receiver characteristics as well as performance requirements. Then the physical layer supports multiple MSS sharing a single physical channel and provides communication between the MSS and the network. Network control handovers are not used in GPRS services. Instead, routing area updates and cell updates are used. The physical link layer is responsible for forward error correction, that is the FEC coding, allowing the detection and correction of transmitted code words and the indication of incorrected code words. Next is the interleaving. What PLL does, it is responsible for the interleaving of one RLC radio block over 4 bursts in consecutive TDMA frames. Next layer is the medium access control or the MAC layer. The MAC layer or MAC protocol handles the channel allocation and the multiplexing, that is the use of physical layer functions because it is above the PLL. The RLC and the MAC together form the OSI layer 2 protocol for the interface. You can also go to the network layers for more details on this. Though we are talking about GPRS here, but if you would like how communication takes place, you can go to the OSI reference model. It is a reference model in networking which shows how the communication takes place between the layers. The GPRS MAC function is responsible for providing efficient multiplexing of data and control signaling on both the uplink and downlink. This process is controlled by the network. On the downlink, multiplexing is controlled by a scheduling mechanism on users, for example, in response to a service requests. Next is mobile originated channel access, contention resolution between channel access attempts, including collision detection and recovery. This is also a function of MAC. Then is mobile terminated channel access scheduling for access attempts, including queuing of packet accepts. packet accesses, and then is the priority handle. Then we go to the next level, next layer. This is the radio link control or the RLC. What it provides, it offers a reliable radio link to the upper layers. What are the upper layers above it? The physical layer, the mag layer. Two modes of operation of the RLC layer are defined for information transfer. These are acknowledged and unacknowledged. The RLC layer can support both modes simultaneously. RLC function is responsible for providing transfer of logical link control layer PDUs, that is LLC PDU, between the LLC layer and the MAC function. Segmentation and reassembly of LLC PDUs into RLC data block. We have the diagram of this below. Backward error correction, that is BEC, procedures enabling the selective retransmission of uncorrectable code words. This process is generally known as automatic request for retransmission or the ARQ. Here is the diagram that I had said that we will see in the diagram in the next page. This is the segmentation of LLC PDUs into the RLC data blocks. We can see there is a LLC frame which has three parts. Then we have the FLC block. Then we have the physical layer. So LLC layer is on the top. Then we have RLC MAC layer. Then we have the physical layer. So we proceed to the next. The next is the logical link layer or the LLC. The logical link control or the LLC layer offers a secure and reliable logical link between the MS and the SGSN for upper layer protocols and is independent of the lower layers. The LLC conveys signaling, SMS, and subnetwork dependent convergence protocol, that is the SNDCP packets. SNDCP exists between the MS and the SGSN and provides a mapping and compression function between the network layer, which is IP or X25 packets, and the two layers. It also performs segmentation, reassembly, and multiplexing. Two modes of operation of the LLC layer are defined. For information transfer, which are again unacknowledged and acknowledged. The LLC layer can support both modes simultaneously. In acknowledgement mode, the receipt of LLC PDUs is confirmed. Since it is acknowledged, it means that whenever a packet is received, its confirmation is sent back to the sender. The LLC layer retransmits LLC PDUs if confirmation has not been received within a certain timeout period. In unacknowledged mode, there is no confirmation required for the LLU PDU, so you send the packet and you don't know whether it has been received or not. We go to this one only and study a bit more about it, how signaling and SMS transfer is done. The signaling and SMS is transferred in unacknowledgement mode. How it is done, because there is no acknowledgement. So signaling and SMS, these are given to unacknowledgement mode, because if you don't receive a received request of SMS, then you can resend. It's not a big deal. In unacknowledgement mode, the LLC layer offers the following two options. First is transport of protected information, means that if error occurs within the LLC information field, the frame will be discarded. Next is transport of unprotected information, means that if error occurs within the LLC information field, the frame will not be discarded. So this is unprotected, and in protected, the frame will be discarded. Next we go to the E. That is the SNDCP or Subnetwork Dependent Convergence Protocol. This is a convergence protocol used to transfer data packets and voice data between SGSN and MS through the IPX25. Network layer protocols are intended to be capable of operating over a wide variety of subnetworks and data links. GPRS supports several network layer protocols, providing protocol transparency for the users of the service. To enable the introduction of new network layer protocols to be transferred over GPRS without any changes to the GPRS, all functions related to the network of network layer protocol data units, that is the NPDUs, are carried out in a transparent way by the GPRS network. This is one of the requirements of SNDCP. Another requirement of SNDCP is to provide functions that help to improve channel efficiency. This is achieved by means of compression techniques. The set of protocol entities above the SNDCP consists of commonly used network protocols. They all use the same SNDCP entity, which then performs multiplexing of data coming from different sources to be transferred using the service provided by the LLC layer. Next is the physical layer protocol. What is physical layer protocol? Several physical layer configurations and protocols are possible at the GB interfaces, and the physical resources are allocated by operations and maintenance procedures. Normally, a G703 or 704 2 mbits per second connection is provided. 2 megabits per second connection is provided. Next, we have the network service layer. What it does, the GB interface network service layer is based on frame relay. Frame relay virtual circuits are established between the SGSN and the BSS. The LLC PDUs from many users are statistically multiplexed into these virtual circuits. These virtual circuits may traverse a network of frame relay switching nodes or may just be provided on a point-to-point link between the BSC and the SGSN. If the BSC and SGSN are correlated, the frame relay is used for signaling and data transmission over the GB interface. The base system GPRS protocol or the BSSGP. The base station system GPRS protocol BSSGP transfers control and signaling information and user data between a BSS and the SGSN over the GB interfaces. The primary function of the BSSGB is to provide quality of service and routing information that is required to transmit user data between the BSS and the SGSN. The secondary function is to enable two physically distinct nodes, the SGSN and the BSS, to operate node management control functions. There is a one-to-one relationship between the BSS-GP protocol in the SGSN and the BSS. If one SGSN handles multiple BSS and the SGSN has to have one BSS GP protocol devices for each BSS. Sorry, I forgot to proceed the slide. The base station, we have layer 1 and layer 2. Uh, the layer 1 and layer 2 protocols are vendor dependent OSI. OSI layer 1 and protocols that carry the IP datagrams for the GPRS backbone network between the SGSN and the CGSN. The Internet Protocol or IP. The Internet Protocol datagram in the GN interface is only used in the GPRS backbone network. The GPRS backbone core network and the GPRS subscribers use different IP addresses. This makes the GPRS backbone IP network visible to the subscriber and vice versa. The GPRS backbone network carries the subscriber IP or X25 traffic in a secure GPRS tunnel. All data from the mobile subscribers or external network is tunneled through in the GPRS backbone. The TCP and the UDP. The TCP or the UDP. The TCP or UDP are used to carry the GPRS tunneling protocol or the GTP PUDs across the GPRS backbone network. TCP is used for X25 data and UDP is used for user IP data and signaling to the GN interface. Next is the GPRS tunneling protocol or the GTP. These are the protocols which are responsible for basically communication between the GPRS systems. GPRS tunneling protocol, or the GTP, allows multi-protocol packets to be tunneled through the GPRS backbone between GPRS supports nodes, that is the GSNs. GTP is defined both for the GN interface, which is the interface between GSN within the same PLMN, and the GP interface between GSNs in different PLMNs. The UDP IP or TCP IP are examples of paths that may be used to multiplex GTP tunnels. The choice of path is dependent on whether the user data to be tunneled requires a reliable link or not. Two modes of operation of the GTP layer protocol therefore supported for information transfer between the GGSN and the SGSN. These are unacknowledged or UDP IP, and acknowledged, that is the TCP IP. A UDP IP uh, path is used when the user data is based on connectionless protocol such as IP. A TCP/IP path is used when the user data is based on connection-oriented protocol such as X25. The GTP layer can support both modes simultaneously. And that was all for the GPRS interfaces. Thank you for listening so patiently, and do listen to the next lectures for more information about the fundamentals of mobile computing. Thank you so much for listening patiently.